So this is a continuation of a video explaining how to do the Throw Something Lab. This is part 2. Where we left off with the last one, we had just arrived at a vertical velocity of 5.2 meters per second. And our original question was, we were trying to get to miles per hour. And so that's what step 5 is going to show us. Step 5 says to convert to miles per hour. You just take that number times 2.24. So that's what we would have here. We would take 5.2, which is 5.2, and then multiply it times 2.24, and that would get us to 11.6 miles per hour. So then we would be a velocity of 11.6 miles per hour. Now, moving on to the next step, step 6 says to find the angle in which it was thrown. And just to go back to our original diagram, what's really saying is, what was this angle right here? What does that equal? And to do that, the easiest way I recommend is to recognize that we can actually just take, this angle here, this y component, if you can imagine, if it's here, this y component, it's right here. If you just move that over to here, and then you just effectively have a right triangle, and you're trying to solve for your unknown here. And to do this, I've just redrawn this here, is basically we're trying to solve for this angle. This is your velocity on the x-axis, and this is your actual velocity. The easiest way, I think, is just to use an existing equation we have that talks about and connects these two relative to the angle. And that's one from your notes, but that angle says that the velocity on the x component is equal to cosine theta times the velocity itself. We have two of these three things, so we can solve it. We know the x component is 3.4. We know that the velocity itself, we don't know cosine of theta, that's what we're trying to find. But we know the velocity itself is 5.2. So if we get cosine of theta by itself, divide by 5.2, divide by 5.2, we're going to find that 0.65 equals cosine of theta. And then I grab my calculator. This is the really common problem I see. This is not the angle. What you have to do is you have to hit the inverse cosine of 0.65. That's going to tell you the angle. So the angle would be 49 point, we can round it to 4 degrees equals theta. So answer to our next column here. The angle is 49.4 degrees. Then finally we need to find maximum height. This is step 7, and we have an equation to do that. So just to jump in here, this is the equation that we're given. I've shown this on the y-axis, it's probably useful. And when I start putting in numbers, it's important to note that time itself, although time, our entire trajectory of this is a total of 0.8 seconds, it's worth realizing that the time, as we go across here, the 0.8 seconds is the entire trip. It's worth noting that the time to get to this apex is halfway through that. So that's why you want to make sure and take half of time. This is a common occurrence that you have to bear in mind with projectile motion. Sometimes it's half. But that's why I put in 0.4 for time. Then this is simple as solving this and putting this together. And we should find that the distance on the y, or the max distance, is going to equal 0.79 meters. So that's our final item here, 0.79. And if we go back to our picture, our original picture, what that's basically saying is that this distance right here is 0.79 meters. And I don't know if that's exactly right, but it's got to be pretty close because it's probably a little bit over a meter, but it's pretty close based on the numbers and the method that we did this with. When you did this yourself, you'll do this with a different set of data, but the process will be exactly the same. Thank you and best wishes.